Hello. Hello, everyone. Happy to see you here at the Champion Conference, which is in its
Hey there.
third day right now. Today we have with us Gunnar Morling from Red Hat. His, I think, real official title is Principal Software Engineer. So he's a great and important person who actually did a lot of open source software that you probably use all day. And today we'll talk about an interesting regression performance testing topic using Jfr unit, Jfr standing for Java Flight Recorder.
Exactly.
I'll leave it to you, Gunnar. Have fun.
All right, then. Thank you so much, Henry, for having me. Thank you really for facilitating the session, and welcome everybody to this talk where I'm going to talk about continuous performance regression testing using a tool which I've built, which is called JfrUnit. And for this session today, I have three goals, three main takeaways, which I hope you will find interesting. So I would like to talk to you about, well, what are performance regression tests and what are the challenges we have with them, and what is, as I think, an interesting approach for addressing those challenges using those tools like JDK Flight Recorder, JfrUnit, another tool called Mission Control, and so on. So that's the first one. The second one then is how can we go about analyzing performance regression tests using the JDK Mission Control tool. So that's another open source tool coming from the OpenJDK project umbrella, and I will touch a little bit on that and how we can use this tool. And lastly, I want to talk about how we can go about a situation where we would like to analyze applications, existing third-party applications, which may not be ready to take advantage of the flight recorder. So maybe they don't emit any flight recorder events yet, and we can see, or we will see how we can go about it using a tool which is called JMC Agent, which will help us with that task. So those are the three things which I hope you will take away from this talk today. A few words about myself. As Henry mentioned, I work as a software engineer at Red Hat. I'm the project lead, the engineering lead for a tool which is called Debezium. Debezium, that's a tool for change data capture. So this means it taps into the transaction log of your database, captures any changes, any inserts, updates, deletes, and sends them to any source of consumers, mostly via Apache Kafka. So you can use those change events then to update the search index, invalidate the cache, all those kinds of things. There's a few other efforts I'm involved with, or I have been involved with. Maybe you've heard about this Quarkus stack for building cloud-native microservices. So I've contributed a little bit there, and quite a few other things. And if you are curious what I'm up to, new releases I'm doing, new blog posts, and so on, then I would suggest you check out what I'm doing on Twitter. So then let's dive into it. And let's first of all explain a little bit what is this challenge with performance regression tests. And now I hope everybody would agree if I say regression tests are a common and well-established practice when it comes to functional testing. So you have built your first version of your application. This has, of course, some sort of functionality, and you add tests to make sure this application does what it is supposed to do. And now if you add more functionality in the next release, well, of course, you would like to be sure in the course of doing so, or maybe you're doing some sort of refactoring, you would like to be sure that you don't break any previously existing functionality. That's always the most important thing, right? And well, good functional tests, they are a regression test for us. So if all our tests, which we had before, keep passing, then we are pretty confident, or we can be pretty confident that we don't have any functional regressions. So I would say that's a pretty established thing, nothing exciting there. Now, things look a bit different when it comes to non-functional requirements, such as performance. So we would like to make sure if we build out our application, maybe we change the code, we reorganize it, we add functionality, we would like to make sure it provides us with the same performance as before. So it should there shouldn't be any regressions in terms of throughput or latency. Our requests and our web service, they should not take longer than they used to take before. Well, because if our regressions or our requests take longer, our users will be unhappy, they will go away, and so on. So we don't want to have also regressions when it comes to those performance aspects. But then, well, how do we implement functional regression, those regression tests for those non-functional requirements? And then that's where it's getting quite tricky because, well, it's just hard to do that. The reason being that all this relies on the characteristics of our production environment. So in order to have some sort of statement about regressions in terms of things like throughput or latency, we need to have an environment which resembles our actual production environment. There's no point in measuring the latency of, let's say, a request if we have a big iron in production, but then we run this test on a small laptop. Or maybe it's the other way around. We have a very powerful development laptop, but then we actually execute our application in resource-constrained containers on Kubernetes. So if we don't have this parity between the environments, then we just can implement those regression tests for performance in a reasonable way. So we need to resemble that production setup, but then also there's of course this question of load. So let's say you were to implement, or you try to implement performance regression tests on something like a CI server. Well, if there's other jobs running, so there's concurrent load, this again will also impact, of course, your own measurements. So you couldn't really reliably measure, let's say, throughput if there's other workloads running on that same machine. So all those things, they make it really hard for us to think about performance regression tests. And this is where this tool, JfrUnit, comes into the picture. So it tries to provide a fresh angle and a new look at this problem. And the general principle is, instead of asserting and measuring those actual metrics which we are interested in the end of the day, like throughput and latency, instead of measuring those, we measure what's called proxy metrics. And proxy metrics are things, let's say, like memory allocation. So how many objects does a specific functionality in our application allocate? Or how much I/O does it do with the file system or with the database? Those kind of things. And the idea is, well, if we measure those proxy metrics, there should be a relation and a correlation to our actual user impacting performance metrics. So if we suddenly allocate more objects for the same sort of functionality than we used to do before, then this might be a strong indicator that this request will just take longer because, well, it does more. The same for database I/O. Or maybe we could think about examining the statements which our application runs. If it suddenly executes many more statements than it did execute before for a particular use case, well, that's again an indication there may be a performance regression. And now the nice thing about relying on those proxy metrics is that they are stable. They are not dependent on the particular environment. So if we have our application, it will allocate the same amount of objects, whether it runs on a big machine or whether it runs on a small machine. We will execute the same amount or the same number of SQL statements, no matter whether there is other concurrent jobs. So those proxy metrics, they're reliable. They don't depend on the environment. And now the idea in JfrUnit is we base our assertions on those proxy metrics, and this will give us some indication that there may be an actual performance regression. And if you have some sort of regression there, or I should say, all this is based on JDK Flight Recorder, and I will show you how to go about it. So this is the source for those data which we then assert against. And if there is any kinds of regressions, we would use JDK Mission Control to dive into the flight recordings and see what is going on. So in a nutshell, it's like unit testing for performance. So that's the tagline, essentially. So that's JfrUnit, and here's how this would look like. So I will show you a little bit more later on in the IDE, but here's the first Hello World example so you get some idea how this is generally working. So it's a plain JUnit 5 test, as you see here, and it's now annotated with this annotation Jfr Event Types. So that's just the sign for the JfrUnit extension to hook into the JUnit execution and take care of this test. Then we have those other two annotations, enable event. And they're there for specifying what are the flight recorder events which we are interested in this particular test. So here, for the sake of the example, I'm just interested in the Jfr event, which tells me if a GC is happening and if a thread sleep is happening. So I enabled those two events, and then if this method is running, the JfrUnit extension will start implicitly and automatically for me a flight recording which has those events enabled. Next, I have this Jfr Events class as a field here, and this is just like a repository which I'm using to access the data which has been recorded by flight recorder in this test. So now, essentially, within the test method itself, I have two big parts. First of all, I have this part where I run my code under test. So this is what I want to analyze. And here, well, I just do the system GC call. I just do a thread sleep for 1 second. And, well, typically, you would, of course, invoke your actual functionality under test. So, like, that's what you actually want to do. That's what you would invoke there. Next, we have this await events method. And that's just like a synchronization barrier, because everything here happens asynchronously. So flight recording data is written to the recording files asynchronously. And this is just a barrier which we need to make sure before we go over to the assertion phase, we have received all the events which have been emitted by this code under test. So this essentially will block until we have received all the events which should result from this code before. And then I can go and run my assertions. So here in this case, I'm just looking for those 2 events. I'm looking for a garbage collection event. I'm looking for this thread sleep event. And well, if they are not present, then this test would fail. So again, it's just a hello world example, but it shows you how you would implement in general a test using JfrUnit. And what you also can see, by the way, is there's a type-safe access to those event types. So you have constants for all the types. You have type-safe access to those attributes like with time. So all this essentially is part of the JfrUnit API. It is auto-generated from the actual Jfr event types which exist in the JDK. And then you don't have to access them in a stringly typed way, but you can access them here in JfrUnit in a type-safe way, which is, I feel, very nice. All right. So now that you, I hope, have a little bit of a broad picture what JfrUnit is about, let's dive a little bit more into the tools we are using here, like Flight Recorder itself and the JDK Mission Control tool. So the Flight Recorder, what is the Flight Recorder? And I would say it's still sort of a hidden gem in the JDK. I feel more people know about it, but still not enough people. So everybody should know about it. And I hope by working on stuff like JfrUnit, I also can help to, well, proliferate the knowledge and the usage of Flight Recorder, which is an amazing tool. So what is it? It's, to quote the docs, it's a troubleshooting, monitoring, and profiling framework, which is built into the JVM itself. So essentially, this means it's a very efficient event recorder, which records events of all kinds in a very compact binary format. And within the JDK, either in the native parts written in C++ or in Java parts of the library, there is code which emits those events at all sorts of meaningful points in time of the execution of your application. So you have a whole range of event types which are built in. So there's events for garbage collection, as we have seen, and they will tell you in much more depth and much more precision what exactly is going on, what kinds of phases, duration, and so on. There's events for locking behaviors, class loading behaviors, the JIT compiler. There is events for I/O and all kinds of things. So there's more than 150 events built into JDK, and the number is ever growing. So with each new release, 17 and surely 18 and so on as well, there are more and more Flight Recorder events which are built into the JDK. But then there's also the ability for you to provide your own custom events. And we will see later on how to do that. So you can have business-specific, domain-specific JFR events, which you then emit from within your application to record information, well, which is specific to your own domain and which you would like to analyze. And now, when it comes to Flight Recorder, there is often this misunderstanding it's a proprietary tool. And this is based just often in the history where this is coming from. So this has been part of JRocket back in the day. Then it was part of the Oracle and the proprietary licensed Oracle JDK. But since Java 11, all this is open source. So you can use it and there's no strings attached. And by the way, it also has been even backported to Java 8. So now in recent Java 8 builds, you also have the ability to use the JDK Flight Recorder fully open source. So it's all there for you, ready to use. Very important is the performance and the minimal overhead of this is a key aspect to it. So it really is meant, or it can be used in an always-on way. So it depends a little bit on the kinds of events which you are tracking, the events which you have enabled. But typically, you can keep this running permanently. It will give you less than 1% overhead on your production application. And you could, for instance, keep, like, let's say, the flight recording data from the last hour. And then if something pops up in your monitoring environment, you could go and grab the flight recording files and dive into the data from the last hour, something like that. And lastly, another thing I wanted to mention, this Flight Recorder engine itself also is now available in native GraalVM binaries. So when GraalVM first came out, it didn't support Flight Recorder at all. But now, just since quite recently, there is support for this also in native GraalVM binaries, which has been some very great work also by some fellow Red Hat engineers, by the way. All right. So now I mentioned there's 150 events and even more, and it can be hard to understand or to keep an overview what kinds of events even exist. And then I found this page very useful, which was created by Tom Schindel, and it is essentially, is generated documentation for all the JfR event types. So you can go to this URL, which you see here at the bottom, and there you have per JDK version 11, 12, 15, and so on, 17. You will see the event types which exist in this particular JDK version and all the attributes and so on. And by the way, Tom also provides here some JSON, metadata or metadata of the events in JSON, which then is machine processable. And this is what is the source for those generated constants and interfaces which we have in JfrUnit. So definitely check out this project. It's very interesting to see what's available in the flight recorder. Now, in order to build a tool like JfrUnit, we want to have access to the JfR event data as it actually happens. So most of the times people use Flight Recorder in this, well, let's say a traditional batch-based approach. You create flight recording files, which maybe download from an environment, and then you load those files into Mission Control or some other tool for analyzing them. But since Java 14, there's this notion of Jfr Event Streaming. So this gives us a real-time, or let's say near real-time event stream with the Jfr event data as it's happening. So we don't have to wait for a recording file, but instead we can hook into this event stream and we can react to events as they occur. Why would you want to do this? Well, for instance, you could use it to drive some sort of monitoring solution. So you could tap into this event stream. Maybe then you do some sort of pre-aggregation to not expose data on a too fine granular level. And then you expose maybe some metrics or some health checks and you feed this into some dashboard. So you could use that to just get an understanding about the health status and the performance characteristics of your live application. You also could do things like predictive analytics. This is something which I find super interesting. So one use case there is you could keep an eye on those JfR events as they occur, and then apply some sort of real-time stream processing to it. Let's say using Apache Flink or Akka streams, tools like that. And you could try to derive some sort of insight into this data. And one particular use case could be you could try to predict when a full garbage collection is going to happen. So before a full GC is going to happen, you will see other events which will tell you, hey, this is likely to happen. And now, well, you probably don't want to send requests to an environment which does a full GC because the user would then have to wait. So you could take this information, you could try to derive, okay, on this particular node in my application, a full GC is going to happen very soon. So I could expose a health check to my load balancer, and this load balancer then would take this information and, for instance, not send any requests for some time to this particular environment, so that no user would have to wait with their requests for this full GC. So that's something which I found, or I think is really cool, and I believe we will see many interesting use cases or usages of this event streaming API. And one of them is JfrUnit. So we will see, or JfrUnit itself is based on this event streaming, and it takes the data to enable those assertions.
Hello.
Yes.
There was a question about is JfR available on Amazon Corretto 8? But I think it's an ELF flavor, or it's
so yeah, that's a good question. I'm not sure whether it is part of the Corretto build, I got to admit. So I know it's part of, for instance, of the Red Hat build. It's part of other builds. I'm not 100% sure whether it's part of the Corretto 8 builds.
Okay. I think yes, because I think it's an open JDK with a little tweak on it, but
okay,
if it's part of the open JDK build, I think it will be there, unless they purposely removed it, and I would be surprised.
Right.
But that's
so I know
guess.
It's not part of the Oracle build, but yeah, I would assume probably it's part of the Corretto build.
Good, thank you.
All right, cool. Then, yeah, so how is this event streaming API used? Well, it's quite easy. You see it here. You have this notion of a recording stream. You need to tell which events are you interested in. So here in this case, I'm using this default configuration, which is a predefined set of events. But again, this could also be more fine-grained for specific event types. And then you just register your event handlers on event, and there you, well, in this case, I just print them out on the console, but you could, of course, also do other things and react to those events. Lastly, you call recording stream start, and off you go. You will have this event stream. This is what is driving JfrUnit under the hood. All right. So that's all the recording side. Now, of course, we also need to, or we want to take a look at the data, right? So maybe we have this production incident. We have the recording, the JFR recording file downloaded. Now we would like to take a look into this recording. And there is the tool JFR coming, or it's just a CLI tool called JFR coming with the JDK, which you can use to poke into event recordings. But really, the tool to go is JDK Mission Control. So this also has been open sourced as part of OpenJDK 11. And this is a very feature-rich workbench, let's say, for working with JFR recordings. So you can analyze all those things like memory allocations. You can look into the profiling events. So you have a method profiler there, which is very good. You can look into the garbage collection events and so on. So really, it comes with many bespoke dedicated views for different event types. You can drill into the data and you can make sense out of them and analyze what's the reason of my problems, which I may have. So that's Mission Control. And there's a few more things. So for instance, it's also a JMX console. It contains a JMX console. You can use it for analyzing heap dumps and so on. So definitely, if you, for instance, are still in JVisual VM, forget about that. Definitely take a look rather into Mission Control. It's implemented in a much better way. And generally, it's the tool which I would recommend for this kind of job. All right. So then it's demo time, I would say. Let's take a look into some tests which are based on JfrUnit. And I want to show you how well you can create those tests and then what you also would do if you identify a regression with one of those JfrUnit tests. And for that, I'm going to change to my IDE. And what I have prepared here is it's a small CRUD application for managing to-dos. So really, it's just a few basic REST endpoints which persist and retrieve to-do items in or from a database. And all this is built using this Quarkus stack, which I mentioned. So it's a very modern way for implementing this application. But this doesn't really matter. It could equally well be implemented using Spring Boot or anything else. But that's what I'm familiar with. So that's what I chose. And now let's take a look into some of those tests. So here I have one. By the way, all this is also in GitHub, so you can take a look after the talk if you wanted to. So let me see what I have here. So this one deals with socket I/O. So the idea is I would like to make sure that this application does just an expected amount of I/O with the database. And the idea being, well, if I suddenly load much more data from my database than I was expecting, well, this could be in a regression. It's something I should look into. So what's happening is I have here this method which just persists a few to-dos in my database just as some sort of setup routine. And now let me take a look into this particular test. And you will recognize the same pattern as before. So I have this enable event annotation. And here I'm interested in those two events, socket read and socket write. So those are the events I would like to track for this particular test. Then I do my actual code under test. And here I'm just using the Java HTTP client to invoke 20 requests. So I just do 20 get to do requests. I have this synchronization barrier to make sure I've received all the events from originating from this test. And then I do my assertions. And in this case, I have two assertions here. So first I count the events, and by, when I wrote this test, I learned, okay, I want to have 2 reads and 2 writes per to do get requests. So that's what I'm expecting here. 2 + 2 = 4 requests. And I'm also asserting that each request does less than, in this case, 480 bytes. So how do I arrive at those 480 bytes? Well, I just took a look at the behavior of the application in time. And then I realized, okay, this is, what it actually does. And I added a little bit of buffer to it. So this is where this value is coming from. So let me run this. Going to run the to-do resource socket IO test. And well, this is using the Quarkus testing framework. So using test containers, this quickly spins up a Postgres database to persist those to-dos, and then it runs those requests. And now, well, I want to show you the happy path first of all. So this one is green. All right, that's pretty cool. Exactly. So that works. Now let me take another look. And now I don't want to, spend too much time with actually modifying the code here. So what I'm doing instead is I am skipping this test, which just passed, and I'm going to add another one which resembles a regression. So imagine maybe you kept working on this application, and now this test here tests a new version of the code. So here, for the sake of the example, I have the good and the bad code side by side. Typically, this would be just a single method, and the diff comes from executing this in different times or in executing the test against different versions of your code. Here I have this side by side just for the sake of the example. But the test is exactly the same. It just invokes another endpoint which represents my regression. So let me take a look. Let me run this one. And let's see what's happening. And now I'm expecting this one actually to fail. So let's see whether that's true. So again, it goes and inserts all my to-dos. And it's going to fail indeed. So let's see what's going on here. And now I cannot really zoom very well in Eclipse, but you see, it's I was expecting those 4 read and write events, but instead I got 18. So this is this assertion which is failing here. So let me or comment this out, and let me see what's happening here with the assertion on the actual bytes. So let's do that. And this also should fail. And we can see what's going on there. So it's integration test. It takes a little bit to run, but it's not too bad. And again, this should fail. And you see here now, I was expecting 500 bytes per request, but instead I almost got 2K. So it's doing 4 times as much database I/O as I was expecting. So that's something to look into. And now the question, of course, is how did we implement this assertion? Well, I just was looking at, or I got, let's say, the event stream here from this Jfr Events class. I filter on database I/O events. So in particular, I'm not interested in I/O events which come from the web layer, any HTTP I/O. I just care about database I/O. And I do that by just, examining the port of the event. So I'm only looking for I/O events which match the database port. And now this gave me those 4 times as much I/O bytes as I was expecting. All right, so now the question is, okay, something is going on here. Something is wrong. We have this regression, but what actually is happening? And for that, well, I would like to take a look into the recording. And now what JfrUnit is doing, it also persists a Jfr recording file for this failing test, or for any test really, which it runs. So this means I can go to Mission Control and I can open up this recording file. So let's take a look. I have my to-do regression here. So let's take a look there. And now I look at the socket IO, and I can dive a little bit in here. And quite quickly, I should see down here in the stack traces where those IO events are coming from. And now, of course, this requires a little bit of understanding of my application. So I would not, as I do it right now, immediately know where to look. But after some time, I probably would find out I have many of those events which have this stack trace, which originates from, let's say here, this particular place in my code. Where is it? You see, let me try and find my stack trace. Here, the to-do resource get with IO regression. So I will find many of those find by ID calls, and apparently they are causing this increased IO. So again, I know, of course, I have written this regression, so I know what's going on, but also you would be able to find out and identify many of those events. So now the next step would be I will go to my code again, and I will try and see what's going on there. So I'll go to my to-do resource, and I have this method get with IO regression. Well, usually it would not be named like that, right? But I see now, okay, I have this find by ID call here, which is on this to-do with avatar class. And essentially what is happening, I or maybe somebody else on the team added this lob field here. So I have an additional binary payload as part of my entities. And this is what's causing this. And now I would think about maybe this is something I could lazily load. I would not have to return the avatar for each get to do response. That's a decision I would have to make. So now I'm also happy with that, and I don't consider it a regression at all. Or maybe the requests take longer, but I'm happy to pay that price. But all of that JfrUnit helped me to understand what's going on here. All right, so that's how you could go about I/O regressions, and I could show you many other things. But I want to show you one other thing, and this is how we can think about analyzing or getting Jfr events from existing libraries. And for that, let me go back to my slides quickly. So here I am. All right. And this is where this tool comes in, which is called JMC Agent. So what is this about? And well, now let's say I have this use case here where I was analyzing this I/O regression, and well, using JMC, I could make sense out of it. But a very important part of the story was really missing. I didn't know what are the actual statements which are causing this. So by looking at these statements, maybe I would have much easier found out what the actual problem is. So well, now the thing is, there's no built-in Jfr event which would tell you about SQL statements which are executed by an application. It's not part of the Postgres JDBC driver yet. Maybe they could do that, but it's not the case. And also, this Quarkus application, this is using Hibernate or M for the persistence layer. Also, Hibernate doesn't itself emit any Jfr events at this point in time. But luckily, I'm still not out of options because I can use this JMC agent, which really is a Java agent for instrumenting existing code. So it will, you will configure it and you will tell it, okay, for those methods, those classes, please emit an event if they are invoked. So that's the trick. And what I'm doing, or what I'm going to show you, is how I configure this thing to instrument, well, not exactly Hibernate in this case itself, but I'm going to instrument the underlying connection pool class to emit a Jfr event whenever a query is executed. And now, then we will be able to look into those queries within Mission Control and understand what are the queries which are executed. And this attaches to an existing application, to an existing code base, so you don't have to modify the code of the libraries themselves. You just can instrument the code after the fact, and kind of magically, I would even say, those events are emitted. You can configure this using an XML file, which is what I'm going to show you. But then also in Mission Control, there's a plugin which actually now lets you configure that in a more user-friendly way, let's say. But for to keep it a bit more bare to the metal, I will just show you the XML-based approach. So then let me go back to my IDE, and let me first of all show you this configuration file. And I am emitting multiple events, one for prepared query, prepared update, and so on. But you just can take a look at one of them, so you see the example, or you see the general pattern. And the way this is working, you tell which class this is about. So in this case, I would like to instrument this class prepared statement wrapper from the Agrol connection pool. I decided to do that instead of instrumenting Hibernate because, well, all the query executions, no matter where they originate in the Hibernate code base, they all go through those few selected methods. So I have, a very powerful means of just instrumenting those 4 methods, I believe, and I will capture all the queries which are emitted by Hibernate, or well, any other tool really which would use this connection pool. So I specified this class here. I need to specify the method. I have this descriptor, which is the method descriptor format as it's known from the JVM spec. And I also can emit some field into the event. So here, essentially, I would like to propagate the value of the wrapped statement field from this class into the event. Later on, I also have, I believe, parameters. Here, for instance, for the execute, or this execute method here, I captured the parameter value, the first parameter with the index 0, which in this case represents the executed query. And this will be propagated as a field into the event. And I also can specify this location here. So I could, emit an event before the method gets invoked or after it gets invoked, or I can do this wrap semantics. And essentially, this just means it will also capture the duration of this method. So essentially, this allows me in this particular case of SQL queries to capture the duration of those, the execution duration of those statements, because they will, if a SQL query runs for 1 second, this event, this Jfr event, will also have a duration value of 1 second. And I could very easily, for instance, then identify long-running statements just by sorting those events by their duration. So that's what I'm doing. I configure JMC Agent to capture those query execution events, let's say. So let me go then to my test. And again, it's the same structure. So I run the a regression endpoint in this application, and I take that right away. I skip the good one for that. You have seen that before. So let me run this. And now in the configuration, I also need to point, I need to enable the agent. I need to point to this configuration file, but it's not so exciting. So just, you can find it in the source code if you want to see how that actually is done. But now this agent is applied. Same thing happens as before. Postgres gets started, some to-dos get persisted, and now I have this regression here. So let's see what's going on. Here, essentially, I invoke this endpoint in this iteration of 20 times, and I was expecting, well, I believe, number of statements, 1 per iteration, I would say. But suddenly I see quite a bit more. So let's take a look there, what's going on. And again, can take a look here. Let me make it a bit bigger. So yeah, it's telling me instead. So I was expecting 10, but it was 60. So I'm seeing 6 times as many SQL queries which are executed here. And I also see all of them here, so I could take a look. But of course, I would like to know, where are those events coming from? Now, I guess you can imagine what's the idea. Well, again, we can go to Mission Control and load the recording for that one and see where those events are coming from. So let me open that file. And this is my SQL statement regression. So let's open that one. And now as those are custom events, which I invented, let's say, there's no bespoke view in JMC for those, of course. But instead, there's this generic event browser, and this gives me the view to all the events which are in this recording file. So now here I see my Hibernate events. So let me make this all a bit smaller. And only the events which are under this Hibernate node here, those are the ones which I have emitted by means of using the JMC agent. So we can take a look at those prepared query events. And we see, well, I have apparently, for each request, I see this cascade of events happening, right? It selects me the actual to-do itself. Then it also selects a to-do detail. So maybe you already have a suspicion where this is going from. It seems a little bit like it's a n+1 select kind of thing. So maybe I could also have made my test a bit more prescriptive or descriptive, instead of just saying what is the number of events I expect. I also could have asserted on the actual tables the selects are going against, and then an assertion failure would tell me a bit more readily what are the additional events. But in this case, I just asserted the number, and still I can see, okay, I have those to-do detail events. And now again, I can take a look into the stack trace here. Again, you would not quite instantaneously, I guess, go to where the issue is, but by looking at the events, you will quite quickly understand where it's coming from. And in this case, surprisingly, it's coming from this method here, to do resource get with SQL regression. So let's take a look at that one. And now this tells me, okay, I'm doing this to do with details here. And well, indeed, I have now this to do detail list here, right? And it's an n+1 select here because I have this lazy association. So maybe I would rather do a fetch join to eagerly load one to do and all its details. But I guess this brings across the general point how you would go and, well, in this case, instrument an existing library and then analyze the events which fall out of that. All right, so that's it. Well, not completely in terms of demo, but for that part. So let me go back to my slides, and I believe we are still doing good time-wise. So let's see. That's JMC Agent. Right, and that's what I wanted to show in terms of Jfr Unit itself. And now there's another effort, another project which I just recently started to explore a little bit over the holidays, and that's called Jfr Analytics. And the idea for Jfr Analytics is to use SQL again to analyze Jfr events. So maybe it's a bit of like an Inception like recursion, but so now I can use SQL to dive into my Jfr recordings and, for instance, find out about events which represent SQL executions. Well, it's quite funny, I guess. And I wanted to explore two things, but Henry, I believe there's a question.
Yes, there's one about. Okay, I'll try to read it because I'm not sure I understand it all. So you can stream Jfr to Prometheus with Java 14, but prior to Java 14 are the usual metric exposed with micrometer equivalent to Jfr events. If don't, any trick to get those Jfr events streamed?
So I'm not 100% sure. So yes, I mean, but I get the question. But yes, so Jfr Event Streaming was only added in Java 14. So if you are still on 8, so this also got not backported. If you are still on 18, you cannot use the Event Streaming API, which comes with the flight recorder since version 14. What you can do is, I mean, you could, of course, try to, for instance, work with various or rather small recording files and emit them in some sort of bursted way, if you will. And also the Microsoft guys, they built some streaming library. I'm not 100% sure whether it does what you are after, but this might be interesting to get in touch with Bruno Borges. He was showing me that to see what Microsoft is doing there. I believe this might actually be helpful.
Was GC Tools you're talking about, or something
No,
else?
no, it's not GC Tools. There was another thing. It was even called Jfr Event Streaming or something. It's a bit confusing because it's not the official Jfr Event Streaming, but some Jfr Event Streaming. I could imagine that could be useful in this context.
Okay, thank you. And there was another down. What does the await event await for exactly? Is it targeting the annotated event types or a particular number of occurrences?
Sorry, what does the await barrier do? Is that the question?
The await events that you use in your test, I think.
Yeah, I see. So what this is doing, there is Jfr Unit itself emits also some events, and it emits some sort of event once the Jfr, once this await call is executed, it will emit an event for that. So, and then it will essentially block until we have received that event. That's the idea. So that's why you have those Jfr Unit sync events in here.
And so it's more for a particular event type, not a number of occurrence, right?
It is just to make sure that we've seen all the events which have been emitted before the await call. So no matter how many, no matter the type, we will just make sure we have received everything up to this barrier.
Thank you. And you're saying that there's effort to stream Jfr data from JDK 8. It seems New Relic is working on it, but it's not there yet.
Yeah, so again, I'm not 100% sure. So this Microsoft project, which unfortunately the name I forgot of, this might help. Otherwise, well, I would recommend you upgrade to later version, anyways.
We try in my case. Okay, I'll let you resume. See you.
All right, thanks. So then, Jfr Analytics. So again, that's a very early exploration, but I wanted to mention it. And the idea is to provide new means for analyzing Jfr data. And it's twofold. So the first one, and that's what I already can show you, is pull-based queries. So I can use SQL for diving into Jfr recording files using a tool which is called Apache Calcite, which makes it very simple to implement that sort of relational algebra based on arbitrary sources such as Jfr recording files. Now you could, for instance, use this you could use it in Jfr Unit if you wanted to, implement assertions just based on SQL queries, which you run against Jfr recordings. Maybe you just find it easier to obtain the data you are after from your recording files using a proper query language instead of having to manually iterate over the events and so on. So that could be a use case. Or you could also use it, for instance, if you have many, many recording files and you want to apply some sort of automated analysis to all of them. So you could run, you would define a set of SQL queries which describe what you are after, like some sort of event patterns. And then you could run that query against all those recordings, and you could quickly understand whether maybe some sort of environment is prone to some particular pattern which you deem problematic. So that's pool-based queries. And then coming back to this notion of predictive analytics, which I was mentioning, I also would like to go and see whether I could apply streaming queries using something like Apache Flink maybe to the Jfr event stream as it is happening. That part is not done yet. It's just an idea. So maybe you're interested in working with me on that. I would welcome that very much. But what I can show you and what I'm going to show you is a little bit those pool-based queries. So let me go to my IDE again, and I'm just going to show you a few of the unit tests from the Jfr Analytics project so you get an understanding of what's going on. So let me take a look here. Simple select from class load, for instance. So here, essentially, I'm getting a JDBC connection. Details are not that important. I'm getting a JDBC connection for a particular recording file, which I've prepared for the test. And then I can run my queries. And the idea is, well, each Jfr event type, that's like one table in this database, and each event attribute, that's a column. And then I can run and implement my SQL queries just as any other SQL query, right? So here I select those things: start time, loaded class, initiating class loader, defining class loader, from those class load events. And now, as I know this recording file, it's something which I created manually, then I can, for the sake of testing Jfr Analytics itself here, I run some assertion against it. So I look for that particular event, for instance. But I can do more exciting stuff. I can, I don't know, let's say some sort of aggregation here. So what's going on here? I am interested, I guess, in the count of classes, right? So I can maybe group it by class loader and understand, yeah, that's what's happening is here. So I, group the number of loaded classes per class loader. So those examples are not super useful, but it tells you, okay, this is what you could do. And you could totally use this in JfrUnit and use this to drive assertions. So that's the JDBC programmatic way of interacting with Jfr recordings using SQL. But then also there's another thing which is pretty cool, and you also can do this in an interactive way. So Calcite, Apache Calcite, the project which I mentioned, which does 99% of the implementation here because it comes with all the SQL parsing and all the relational algebra implementation. This also comes with a tool which is called SQLine. And SQLine, that's an interactive SQL shell, which I can then use to run some queries using Calcite. So I'm just running this here in the context of the Jfr Analytics project. So I have the right class path and everything. Now this gives me this shell. And now the first thing I need to do is I need to connect. And I connect, in this case, not to a database, but I connect to a Jfr recording file. So I'm using some sample which I've prepared here, the object allocations Jfr recording file here. User and password don't matter. So I use those dummy values. And I'm using this custom schema factory. And so that's the link between Calcite and my custom implementation here. So let me do this connection. Now I can take a look at the tables which exist there. And this will tell me, okay, there's one table per Jfr event type. And I also can take a look at the columns of an event type. So let's say JDK object allocation sample. So let me see what columns this table has. The Jfr event attributes. So like start time, thread, stack trace, and so on. All right. So now let me take a look at my little cheat sheet here. So I want to I'm going to transpose the output format. So instead of having an output in a table-like fashion, I want to do the output a bit differently so we just can see it a bit better. Then I'm going to run a pretty cool query, and I'm going to run you through that. So what's happening here is I'm querying the object allocation sample events. So that's my table. And I am just interested in a specific time frame. So I have this reset call here, which essentially is just there, to exclude some events after some sort of warm-up period. So typically, if you have an application, it will do more allocations at the startup. At some point, it should be in a sort of a steady state. And now this steady state, that's what's interesting, right? Because if you allocate more than you would expect during the steady state, this could, than you was expecting, then this could be interesting. So that's why I limit this start time here, and I truncate my stack traces. So I'm just getting 40 lines per stack trace. So that truncate stack trace function, that's a custom function which is part of Jfr Analytics. Per stack trace, I sum up the weight. So that's essentially a representation of the allocation that happened. So I sum up those events, and then I group it by the stack trace, and I order it by the sum in a descending way, so that in a descending fashion. So all this is essentially to give me the, in this case, 10 most allocating stack traces. So, oops, that is what this is doing. So let me go a little bit to the top here. So that's the top most allocating stack trace out of all of those which exist here. And again, now I could look, of course, for my own code in this application here. So, and well, that's not from this example. Oops, what did I do? No, which isn't about an allocation regression. So, well, obviously this works pretty good. Usually you wouldn't have named your method like that, right? But you will be able, by using this simple query, to understand what are the allocation heavy places in your application. And again, if you do this in reasonable timeframes of your application, like the steady state, then this will be very interesting to see what are your top allocators, and maybe there's something which you want to do about them to allocate less. So that's pretty much the idea. And you could, of course, have other queries, I don't know, to identify classes which are loaded multiple times, to identify your SQL statements, to make it a bit meta-circular. What are your SQL statements which run the longest? All this kind of stuff. So I feel having the means of running arbitrary SQL queries against the JFR recording, this could be a very powerful and flexible way of gaining insight into JFR data. All right, so that's it on JFR Analytics, and I'm pretty much done, I believe. So let me go back to my slides, and I want to wrap it up. So yes, time-wise, it looks good. I hope I could bring across the case that with JfrUnit and, well, by extension, Jfr Analytics, we have a very powerful and robust tool for implementing performance regression tests. So, instead of only finding out about the performance regression in production when it's way too late, we can use this tool to identify potential regressions early on. So even in our ID, we do some code change, and we will be able to find out early on during the development that there may be a performance regression. So this means faster feedback cycles. Obviously, it's much cheaper than to react to such a fix, and we won't even roll out such a regression into production. Of course, as I mentioned, well, all this is based on the idea of measuring proxy metrics, right? So instead of the actual metrics like latency or throughput, by measuring those proxy metrics, we have very robust means of implementing those tests. And we can use them, again, to find out about regressions, or potential regressions, I should say, early on. So why am I making this point about potential regressions? Well, all of this requires some pretty good understanding of what's going on. So as we have seen in this case of the this IO regression, so maybe this additional IO with the database, this is actually something which we deem valuable from a business perspective. Maybe this is expanding the use case, the functionality, and this makes sense. So in that case, it's not really a regression. We would rather go and adjust the assertion of this particular test. But on the other hand, if the application hasn't really changed, or maybe it has changed a little bit, but we see a substantially larger amount of I/O, maybe that's something then we want to look into. So this, it requires some proper understanding about the semantics and characteristics. It's not that if such a test fails, automatically it means something is wrong. Rather, you should then go and look into it. Also, it won't help you with all kinds of problems, right? So let's say you have some sort of locking primitives somewhere. Maybe a performance problem with those would only show up if you have some actual high load, only if there's some actual contention. You wouldn't easily find out about that using JfrUnit. You might use it, but it would require a bit of a bespoke or thorough testing. And lastly, it also would tell you, this tells you about performance regressions within a Java application itself, right? So let's say your database query itself it gets bad, the execution plan changes in a suboptimal way. Well, we would not find out about this sort of performance regression using JfrUnit. So it's not for all kinds of problems, but I believe there's a reasonable problem category where this tool can be helpful. In terms of what should be takeaways, well, again, I believe it's a tool which can be useful in your toolbox for implementing performance regression tests. You should not rely on it all by itself. It's a complement and in addition to other tools. In cases where you are not in control of the source code, so think about the SQL statements, you can use JMC Agent, which, by the way, is a project which is part of the Open JDK JMC project. I should be very clear about it. So you can use this JMC Agent then to emit events, Jfr events from existing code, and it allows you, to get many more events which you otherwise couldn't. And on a meta level, well, move beyond Java 8. We saw it actually in the questions already. I really recommend to move beyond Java 8. There's many more event types, speaking about Jfr in particular, but then there's also many other features like event streaming, many other things in Java 17. So really, if you are still on 8 in particular, I would definitely recommend to move on and benefit from all those improvements. Also, the garbage collection, by the way, substantial improvements. So really, you shouldn't hold out on Java 8 any longer. In terms of an outlook, where could JfrUnit go? Well, one of the things I would really like to do is I would like to explore how we can analyze historic trends of our data. So let's say we have a case, it's a little bit like the frog in the boiling water. So things are getting worse and worse just slightly over time. So maybe each day there's a small regression. And now, each a single one by itself may not be a big problem and you might miss it. But then if you look at the data in the course, maybe from, as it developed over half a year, maybe then this will tell you, okay, well, all this together, this actually is a problem. So something is wrong here. So I would like to see how we can use tools like Horium from the High-Profile project, which is microservices performance benchmarking tool from the Red Hat performance team, how we could use such tools to build a repository with historic data to gain an insight and understand and analyze those long-term trends. So you could even do some sort of machine learning, I don't know, some sort of signal recognition on those graphs to understand trends which evolve over a longer time. So again, if you are interested in that, I would be very happy to talk more about this with you later on. Lastly, a few resources. All of this is open source. As I mentioned, JfrUnit, it's there on GitHub. There is a blog post which introduces it on my blog post. By the way, there's also one in InfoQ, which somebody else wrote, so you can read about it there. There's a few cool posts about the JMC agent on the Red Hat developers blog. And also, there's this project Container JFR, which is very interesting, as it allows you to gain insight into JFR recordings if you run your applications on Kubernetes. And then, for instance, there's a web view, so you can analyze your JFR data right from within your browser without even having to download a file onto your machine. So you can load it into Mission Control. So also definitely, if you are on Kubernetes, check out Container JFR. All right, and I believe that's pretty much all I got for you. We have definitely time for questions. We can go beyond the top of the hour, but for now, that's all I had. And yeah, I would be happy for your questions. Thank you so much so far.
Thanks a lot. It was great, actually. I'll need to watch it again because you gave tons of tools I wasn't aware of. So
okay,
I'll dig into it. I'm happy to have moderate.
Awesome
presentation. There was no question. There's a comment by Kurt who's saying one of the issue with JFR is that the timings are estimated, and unfortunately, this result is a significant amount drift in the timestamp for each event. Then significant might be not significant for most people, I think. Maybe significant for Kirk.
Right. Okay,
so-
yeah, interesting. I haven't heard about it, but it could be, yeah, in a particular use case. So it's Kirk Pepperdine?
Yes.
Oh, okay, yeah, it could be a Kirk only problem, maybe.
But I'm guessing it's a millisecond drift or maybe nanosecond drift.
Right, something like that.
So I don't have that kind of tolerance. And apart from that, everybody seems happy. If anybody has a questions, please do it now. Otherwise,
stay silent forever. No, I mean, people can hit me up by
Exactly.
email or can hit me up on Twitter. So we also can discuss what those means.
And otherwise, yeah, you have can be minutes, he's saying.
Oh, really? Okay, that's interesting.
That's strange. And otherwise, everybody's happy.
Okay.
So thank you very much. I'm not sure I've presented myself at the beginning, so I'm but moderator was today Henri Tremblay from Montreal. If you happen to be there, say hello. And it was a pleasure to have Gunnar with us for J Champion Conference. Oh, and there is a question. You want to still a question?
Yeah, sure.
So, would some level of parallelism and asynchronicity in the implementation affect the result capture event and then the test result?
Ooh. Well, I guess it depends on what exactly you do. But I mean, there is parallelism already happening, right? So let's say such a web stack like Quarkus, it would have multiple worker threads. So one of the things which is interesting, of course, is you might, for instance, be interested only in events originating from specific threads. So there would be considerations like that. But in general, I don't think this would affect the overall idea of that. It might just require more consideration of what's the data or what's the subset of data you're interested in, maybe.
Yeah, I don't think of course asynchronicity will cause problems. You need to make sure your thing is done before benchmarking and
right, exactly.
But that's for everything, like it's a unit test.
Exactly.
Another question about like the code example you shown. Where are they?
Oh yeah, right. That's a good point. So that's all. So there's this Moditect organization on GitHub, and so the actual project itself, it's JfrUnit, but then there's also JfrUnit -examples, and this is where all those example code is living, and also this Jfr Analytics exploration. That's also part of this Moditect umbrella. So it's all under the Moditect org.
Excellent. And now there's another question by Kirk
that
I do not understand, but I will ask it.
Sure.
Can you comment on how this level of testing accounts for scalar replacement?
How it accounts? Okay, to be honest, I believe this is really unrelated. I mean, I wouldn't see how scalar replacement impacts JFR metrics. I mean, I'm a bit out of my league, but let's say there could be JFR events which are very specific about some aspects from the JIT compiler, and maybe you were doing some sort of assertions against those JIT compiler events, and they are impacted by a scalar replacement. This could be, but really I haven't tried, so I guess it's a matter of giving it a try and see what.
What is this? What is scalar replacement?
Yeah, so let me try. I can try and explain. So if the compiler detects that some attributes, some fields of an object which gets allocated, they don't leave some scope, so they are not returned by a method, then it can allocate those attributes directly on the stack instead of allocating this object shell, let's say. So I guess I'm saying something which isn't 100% clean, but that's the general gist of it.
Okay. I wasn't aware that was the name for that thing. Cool.
Right. So yes, that's what's happening. I mean, so what the JIT in Java isn't doing is like this stack allocation instead of allocating objects on the heap, but it does do this scalar replacement if the escape analysis tells, okay, it's safe to do that.
Excellent. Another thing learned. So again, we're out of questions now. So
All right.
again, thank you very much for me here. It was a
Thanks.
pleasure to have you and moderate.
Absolutely. Thank you for having me, Henry. I really enjoyed it. Thank you so much.
That's no problem, and hope I'll see you soon. Ciao.
Most definitely. See you. Bye-bye.
And